This month's MBT will focus on standpipe operations. Before we discuss operations, let's do a quick review of standpipe systems in general. NFPA 14 defines 5 types of standpipe systems: automatic wet systems, automatic dry systems, semi-automatic dry systems, manual wet systems, and manual dry systems. Although there are 5 types of standpipe systems, this MBT will mostly focus on the automatic wet systems that are most commonly found in Montgomery County. Apart from the 5 types of systems, standpipes are also broken into 3 differing classes. Class 1 systems. These will provide a 2.5-inch hose connection for use by the fire department only. These systems, as a whole, will supply at least 500 gallons per minute at the uppermost floor of the structure. Class 2 systems. These systems are designed for occupant use in combating a fire until the fire department arrives. These systems provide an 1.5-inch connection and are often equipped with fire hose and a low flow nozzle. They provide a limited supply of about 100 gallons per minute. Class 3 systems. These systems are designed for both occupant and fire department use. These systems will have both 2.5-inch and 1.5-inch connections, or it will be equipped with a single 2.5-inch connection and an adapter to reduce the connection to 1.5 inches. This connection is capable of flowing at least 500 gallons per minute. An important note: Montgomery County Executive Regulation 19-13, entitled Fire Protection Systems, prohibits Class 2 and Class 3 systems from being equipped with hose for occupant use. Each standpipe system may have a slightly different configuration or layout, but the common components should include the riser, a hose valve, an outlet, a valve handle, and a cap. One important piece of information to be aware of is the presence of pressure reducing valves, pressure restricting valves, and orifice restrictors. These devices are often required in taller buildings equipped with fire pumps. The fire pumps can generate the high pressures necessary to reach upper floors. However, if these pressures were to reach nearby floors, they would cause damage to sprinkler systems, as well as safety issues for firefighters operating hose lines. These devices can have catastrophic consequences if they are undetected, improperly set, improperly installed, or not maintained. We will review examples of each of these devices, but it is critical for MCFRS personnel to be aware of their existence and operations before an incident takes place, and be prepared to override these devices if a device failure occurs. A pressure restricting device or pressure restricting valve is an exterior device attached to the hose valve that will limit or restrict the opening of the valve and therefore affect the flow and pressure available in the system. In this example, the hose valve is equipped with a device that prevents the valve from opening fully. Depending on the manufacturer, this device can be broken off if needed, but care must be used to avoid damaging the valve itself. It is best to use a tool, generally an Allen wrench, to remove this device. This hose valve is equipped with a similar device, but is equipped with a limiting pin. Simply remove this pin to adjust the device as needed. Some hose valves are equipped with orifice restrictors. These devices obstruct the outlet connection to reduce flow. These devices are generally easily removed with a small screwdriver, a spanner wrench, or even channel locks. A pressure-reducing valve is a valve that is engineered and preset by the manufacturer and then installed on site. These valves are generally identified with the large, smooth ring. These valves are not field adjustable. Several newer versions of the pressure-reducing valve are being installed in buildings. These newer style valves are considered field adjustable by firefighters using an adjustment rod. During your pre-planning, the location of these adjustment rods should be identified, if not carried, in your high-rise bags. The way these devices are adjusted will vary with the manufacturer, but in most cases involve placing the rod into the opening and spinning the valve left or right, as indicated on the sleeve. Using a manual standpipe system, we will now review some basic standpipe operations. Let's start by taking a look at deploying the bundle pack. Once removed from the engine, firefighters may benefit from draping the bundle over their cylinder. This disperses the weight evenly across their shoulders, back, and hips. This also frees their hands for carrying extra equipment or for using hand railings for longer climbs. Upon reaching the floor below the actual fire floor, stop and prepare to hook up to the riser. Connecting to the floor below is a NIOSH recommendation due to the possibility of conditions deteriorating on the fire floor prior to having the hose line in service. It is important to flush the riser prior to using it. This helps remove any corroded metal or other debris from blocking the connection or the nozzle. Broken off pieces of corroded metal are more likely to clog a fog nozzle. Because of this, a true smoothbore nozzle is preferred. Always keep in mind, flushing the standpipe system can cause the floors to become slippery. After flushing, the backup firefighter attaches the hose line via the gated Y or reducer. The choice of appliance used is really the officer's discretion based on conditions found or expected. However, if two lines are operated from the gated Y, this information must be communicated to the pump operator. While the backup firefighter flushes and connects to the standpipe, the nozzleman advances up the stairwell, usually one floor above the fire floor. Remember, it's important to keep the hose line to the outside of the stairwell and landings. This prevents the hose line from getting hung up on the railing corners, and it makes moving in the stairwell much easier. Ensure the hose line will not get pinched or caught under the railing. If manpower permits, have a firefighter kneel on the hose line at the top or halfway up the stairwell prior to charging the hose line. This will prevent the hose line from coming back down the stairs unexpectedly as it's charged. Once the hose line is in place, the backup firefighter should turn the standpipe valve slowly until fully open, then reposition to assist with hose line management. The nozzleman will check the pattern and bleed the hose line, after which the team will prepare to make entry onto the fire floor. The officer's pack and second bundle should be ready in case appliances are needed and/or the hose line needs to be extended. In areas where space is a concern and stretching the hose line on a stairwell is not practical, the bundle pack can be deployed using a technique called propped loops. Place the bundle pack on the ground and undo the buckles. Keep the nozzle side close to your knees. Place the nozzle against your knee and alternate placing a loop around your arm. The backup firefighter will attach the hose to the riser. Reach both arms through the loops and step through the loops with one foot. Use your back foot to heel the nozzle. Slowly charge the bundle. Adjust the loops as necessary to stand them up against the wall. The hose line will advance with ease, and the backup firefighter can roll the loops down the hallway. Remember, this deployment method should only be used on the fire floor landing when conditions allow. Now, we'll show some troubleshooting techniques along with some alternative methods to consider. A well-equipped officer's pack, like the one pictured here, will help with problems encountered with standpipe operations. A spare wheel may be needed if the wheel is missing. If your bag is not equipped with one, A pipe wrench may be used to open the valve. A pipe wrench can also be used as leverage to assist in opening tight and unmaintained valves. Paint or buildup of other materials on the threads can be wiped off with a gloved hand, or struck with a spanner wrench to knock off the debris. A plastic cap that is stuck can be struck with a spanner wrench and broken. When deploying a hose line in a stairwell, be sure the hose line is not under railings before charging. Though code permits a maximum of 200 feet between a riser and the furthest occupied living space, crews should be prepared to extend the hose line beyond that 200 feet. A minimum 200 feet of hose should be brought into a mid or high-rise building. Crews should train and practice on methods for overcoming a standpipe system being out of service. Hoisting a hose line up a stairwell. Operations on tight landings and in crowded stairwells are but a few suggestions. In cases where more gallons per minute are needed, the deployment of a 2.5-inch standpipe pack should be considered. As you can see, the deployment steps are the same, except the hose line is connected directly to the riser. Thank you for watching this review of Standpipe System operations. Please take the time and learn about the standpipe systems in your area and throughout Montgomery County. Practicing standpipe system operations will help ensure you and your crew will be prepared when this valuable skill is needed.